This is lesson 1.2, displaying quantitative data with graphs. Now, I've been told that I am a lot more interesting in real life, so I'm trying to learn some new tricks on our software here. So last class, I showed you how I could make arrows, and I was really excited about the arrow thing. And I'm learning about those a little bit more. And today I have to show you my new tool that I figured out, and this is the laser pointer. Woo! I know it's pretty and very exciting. So this is lesson 1.2. One of these days I'll figure out how to put myself in the corner and I can video and you can see my face. All right, let's get started, shall we? In this chapter, in this section of the chapter, we're going to learn about a variety of different graphs. We're going to start off with dot plots and use those to describe the shapes of plots. Then we'll be able to compare distributions. Then we'll go to stem plots and then histograms. Histograms are perhaps the best, easiest and most commonly used graph for data, especially large quantities of data. So we'll go through each of those sections. So, dot plots, wow, really, really intense things. Dot plots, we have 3 steps for dot plots, and then we're going to try an example. And I know this is going to be too exciting for you, so just hang on. I think you guys can handle it. All right, so let's get a little bit better color here. Let me see. I think we'll write in green today. Oh no, maybe pink. All right, so step 1, we're going to draw a horizontal. Okay, I need to erase that because I just can't abide that. We're going to draw a horizontal axis. Now, even though this is a dot plot, we still want to at least tell what, label that horizontal axis so the reader knows exactly what we're measuring. Step 2 is we are going to scale the axis. And step 3, we are going to mark a dot above the location on the okay, see, I can't talk and write at the same time. I don't know how I became a teacher. Location on the horizontal axis corresponding to the value of each data. Now, I do love dot plots because they are a down, quick, dirty little way to go, and you can see quickly how the shape of the distribution is going to form just by plotting these quickly. Now, obviously, if we have a great number of data points, we probably don't want to do this because nobody wants to plot 10,000 points. That's when we go on to other things like histograms. So let's try an example. Look, I put pictures. You like the picture? Ooh, pretty colored dot. All right, so we're going to do a dot plot of this data. How good was the 2004 U.S. women's soccer team? And we know that they won a gold in the 2004 Olympics, and they were amazing. I believe that person right there, let me go back to my dots here. I believe that is Mia Hamm, who is married to a baseball player, but the name escapes me right now. All right, here are the data on the number of goals scored by the team in the 34 games during the 2004 season. So right here I do have an error. This is not a, number 3, number 4, number 5. These are actually numbers. So what we're going to do in order to make this dot plot is we are simply going to put a dot above each one of these, for each one of these data points corresponding down here to our graph. Now, when I did this graph at home, we had a little bit more space, and when I moved it in when I converted it and put it into the program, it's chopped off quite a bit. But I'm just going to put over here, I'm going to label this number of goals scored. And this would go underneath your graph. And this is actually per game. All right, so we're just going to put a dot. And when you do your dots, you want to get them pretty similar on as far as level, and you'll see what I mean here in a minute, we want to get them to match. We don't want them all over the place, or we can't get that good indication of the distribution. I'm going to have to write these a little smaller. I didn't think there would be this much data here. 2, 2, 2. Excuse that I'm going up. 4, 3, 5. 5 needs to be a little higher. 6, 1, 5, 5, 1, 1, 5. All right, so we can see the data that we have plotted. It's kind of interesting. Very few games, only one game did we have 0, 6, 7, or 8 goals. I mean, eight goals would be insane. But we have sort of a peak here. Whoops, let me use my laser tool. You see that it kind of goes up here, and then we kind of go down. And then we have another peak here, and then this flat space. So we can learn quite a bit. The average number of goals would probably, if we averaged them all together, would be somewhere around 4. But you can see they're most likely to get between 1 and 3 goals. But then 5, they often got 5 goals. So quite an impressive team. That's how you make a dot plot, only probably prettier than mine. Now, we want to examine the distribution of a quantitative variable by looking at these graphs. So we're in the graph, we want to look for the overall pattern. Whoops, go back to writing. The overall pattern. And for striking departures from the pattern. And when we are looking at a graph of quantitative variables, we're going to use our SOX. SOX stands for S, shape, O, I don't know why we have that. Outliers. There we go. C, center. And S, spread. Shape, outlier, center, spread. We'll be going over each of these. Now, center and spread. Center and spread, the center is really looking at the center of the data, whereas the median and the mean, which we'll go into detail, I believe, next section. And then the spread is how spread out is this data? Is it really close together? Is it spread apart? We noticed before in the previous example we had between 0 and 8, and it was somewhat spread out. Sometimes we'll have data that's very, very close. So a measure of center and a measure of spread are really important. And we're not going to spend a lot of time on this now, but there's some general bits of information that we can get about the graph. And this is a picture that we'll actually look at later on, showing a graph. And we are going to talk about the shape of the graphs in a bit, and I'll come back, and we'll maybe not come back to it, but I'll remind you that this has a specific shape, and it's skewed. All right, so let's do some key vocabulary. These are types of shapes. All right, so symmetric is if the right sides and the left sides are approximately mirror images of each other. So if I had a graph here and I had data that looked like this, you can see that I pretty much have a mirror. If this was the middle, I'd have a mirror image on both sides. That's primarily symmetric. truly, we do not have a lot of symmetric things. Most distributions are not symmetric. It's a very rare anomaly. Then we have skewed. Skewed means if the graph is longer on either side. Now, the skewness goes to the what I call the longer tail. So if I have a graph like this, this is going to be skewed to the left because the longer tail is on the left. So this would be skewed left. Likewise, if I had one like this, we can see that this slope is longer, this tail is longer, so that is skewed right. You always go to the side that the tail is longer. All right, we also have one called uniform. Uniform means that everything's pretty much the same. Uniform is straight across, usually. Obviously, not something we get too often, but if we were going to have a graph, it would be like this. Maybe one that was off a little bit, but primarily always the same. That would be uniform. Now we have some different types of modes, bimodal, and then I'll also tell you about multimodal. Unimodal means you have one peak. Bimodal means you have two peaks separated by a valley. And that would look something like this. If I had some data here, let's say I've got this peak over here and then it drops down and then I'm really low here for a while and then I go back up and then I drop down. Notice that I have two peaks. I have a peak here and I have a peak here. So bimodal meaning two peaks. Now you can have multimodal, which is really three or more. And you can have unimodal, and I'm assuming most of you can figure that one out. Unimodal means one peak. And we'll be looking at different distributions and determining what type they are. All right, so here's some examples of different graphs. Now let's look. We see that this one kind of goes up here, and then it's kind of dropping down. And really and truly, for all intensive purposes, the dice roll graph is somewhat, I would say, pretty much unimodal. We have one big mode, and I would call this unimodal. This one is also unimodal, and this is really kind of unimodal symmetric because it's very similar. This would be unimodal, and this is skewed, and you don't always have to write unimodal out there. Skewed, and notice my tail is longer on this side, so skewed left. And this one's clearly bimodal. I'm sure I put in a blank slide here for something, but I'm not quite sure I remember why I did it, so this is just our blank slide. So I guess this means this is your relaxation time. Relax, stretch. You can pause me now. All right. All right, so now we have some more descriptors that we're going to use. Some other things that we use to describe the graphs that we get. But we already talked about shape and the different types of shape we had. We also have center. Center is, where's the center of data? And primarily we're going to use two. We're going to use the mean and the median. Another measure of center would be the mode. We don't use that too often. Now spread. A spread tells us the amount of variability in a set of data. And a common measurement that you know would be the range. The range tells you the spread of data. It's the difference between the highest point and the lowest piece of data that you have. Another one that we're going to learn about and use a lot, actually two more, we have the variance, which we will learn, and the all-important standard deviation. Measures of spread in statistics are vital. And then we have outliers. Outliers are things that depart from the norm. We'll be going over this more next section, but basically there is a mathematical computation for finding if something's an outlier, other than just it looking odd, and we'll go over that in a bit. We do have a very practical way, so you don't have to make judgment calls, so don't worry about that. All right, well, we're back together, and I did not finish this when I got home. I did it. I'm doing it on Tuesday, so I apologize, but I was tired, and I hope you guys got some rest. All right, let's go back over this question very quickly about the estimated fuel efficiency for 24 model year 2009 mid-cars. And you can see all of our information is here, as well as a nifty little dot plot that someone has given us. And right now we just want to describe the shape, center, and spread of the distribution. So let's look and see what we've got going on. Well, first of all, it looks like we have 3 clusters of values. I have a cluster here, I have a cluster here, and here. So there are 3 clusters of values. And those occur at 25 miles per gallon, about 28 mpg, and 35, I can't read that, but 33 maybe? 33. And because I have three peaks, I would call this multimodal. I can also see that we have a few outliers here, potential outliers, because we're not sure yet, we can call them that. But the potential outliers would be the Bentley at 14, and the Rolls gets 18. Now, we don't know that those are outliers, but we're looking at these two, and we can see they're very far off of the basic dot plot. Now, if we were going to talk about the center or the mean, we would simply just count. So we count 1, 2, we know there's 24, so 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So you know it's going to be between 12 and 13, which happens to be the same number, which is 28. So we know the center is 28 miles per gallon. And so a typical model year would get 28 miles per gallon. As far as the spread, the only thing we know to use would be the range. And the range would tell us that the difference is 33 minus 14, which is 19 miles per gallon. So that pretty much sums up what we see in this. All right, moving on. We're going to look at stem plots now. And the stem plot is the same thing as a stem and leaf plot. Now, you guys have done these before. I know you started doing these in middle school. So this should not be too difficult. So let's talk about the steps to making a stem plot. So first of all, you choose the stems Second, you add the leaves. Third, you order the leaves. And the fourth one, which is really important, so make sure you remember this, is to add a key. If we do not add a key, we don't know what we're telling our reader to look at. So let's look. We're going to do a quick one. And this, I believe, is actually from your book. How many pair of shoes does a typical teenager have? So we want to use this data. Again, I don't know why it's putting decimals in here in my PowerPoint, so please forgive me. I can see in this data, because we are looking at things in just in the tens place, that I'm going to make my stem the tens place and my leaves the 1. Now, you don't, sometimes if you're in the hundredths place, you're going to, if you're looking at different hundreds, you're going to change it a little bit differently. So it is kind of a difficult thing. I think we'll do another one in a bit that shows you to use a different, not just one place value for tens. So here we go. We're going to make this. The stems are going to be starting at 1, going to 5. We see that that's where our data is. 1, 2, 3, 4, and 5. There's our stems. Now we're going to add our leaves. Now I will tell you that most of the time it's a lot easier if you pre-order this data. So what I would do, just a little hint, when you're doing these stem and leaf plots, for time's sake, use your list on your calculator and then sort them. So that's what I've done. I've plugged these into my calculator and I've sorted them, which is going to allow me to do this a lot faster. So I see that I'm going to have, I had 3 13s, 1 15, 1 19, 22, 23, 23, 24, 26, 26. It's important that you line these numbers up. If you do not, it will not work. I have 30, 31, 34, and 38. 49 pair of shoes. 50 pair of shoes, really. 50 pair of shoes as a teenager. Holy cow. That's more shoes than I have, and I got a lot of shoes. All right, so now we can see our nice little stem and leaf plot. But are we done? No, Mrs. Byrie, we're not done because we did not include a key. And if I don't put a key, I'm going to get a bad grade. All right, so here's our key. I'm going to put this, I usually put this down at the bottom. You can put it over here on the top. But basically, you can just choose whatever. Your key looks like this. You just do like, I'm going to use 49. You do this, and then you say, that represents a female student who reported having 49 pair of shoes. All right, so here's another example, and this is one that's a little bit more difficult because you see that we've got our our data here is in hundreds. Instead of tens, it makes it a little bit more difficult. But what I do notice is that all of this data falls between, it looks like to me, 150, the range is 150 to 190 basically. I think it's 187. Something along that line. So it's going to be, in this case, because we're falling just in between these two, this range is fairly small, it's only 20, then we're going to put our stems after the tens place. So I'm going to do this quickly because I'm assuming you guys can do this. So here's the male for the males. And again, I've already put my data into my calculator and I've sorted it, which helps me immensely. So I've got, sorry. All right, so I've got a basic one, which would be pretty easy, 15, 16, 17, 18 as my stems. My leaves would be 1, 4, 7, 9, 2, 3, 5, 5, 7, 9, 4, 5, 6, 7, and 0, 3, 7. Now this is fine, but in this case, and I would write down my key, 15/1 is a male, 151 centimeters tall. Now that's nice, but it's a pretty vague description or distribution. So one of the other things we can do is we can do a split stem. And if we do a split stem, we basically have two stems. One, like 15 will be twice, so let me show you what I mean. This is split stem. A split stem would look like this. I'll have to write really small. 15 will have two stems, 16 will have two stems, 17 two stems, and 18 two stems. What this allows us to do is we're going to split. The leaves will all be 1 through 4, or 0 through 4 for the first stem, and 5 through 9 for the second stem. So this would look like this. 1, 4, 7, 9, 2, 3, 5, 5, 7, 9, 4, 5, 6, 7, 0, 3, and 7. That gives us a much clearer indication of where most of these ranges tend to be. So most of them, I mean, we could see that 16 is our biggest group, but it's really over the 165 mark where we're right in the middle. So split stems can be beneficial because they just give us a little bit more. Now, in addition to doing a split stem like this, we can also do a back-to-back stem plot. So I'm going to do a back-to-back up here and use both the male and the female. So here's our back-to-back stem plot. These are handy when you want to look at comparisons. So I'm going to put the females over here and the males over here. And in order to compare, we want to use the exact same stems. And I'm going to split the stem because I like to split, which gives me more information. So 15, 15, 16, 16, 17, 17, 18, 18. Our male side will be exactly what we've already done. 1, 4, 7, 9, 2, 3, 5, 5, 7, 9, 4, 5, 6, 7, 0, 3, and 7. But our female side is going to be a little bit different. You do not have to change colors, by the way. When you do your female side, we're going to work from the closest one to the stem is going to be your lowest. So we kind of work backwards. So this is going to be 2, 3, 3, and then 7, 8, 8, 8, 9, 16, 60, 0, 0, 1, 3, 3, 4. 1, 3, 3, 4, and 5, 5, 6, 6, 7, 8, 9, 9, 2 9s. So now we can compare male and female in a quick chart. The back-to-back is time-saving and is very, very handy. And it compares the heights easily. All right, when you're using a stem plot, there are a couple of things that need to make sure that you realize. Number one, these do not work well for large data sets. Okay, let's just erase that. All right, start again. Do not work well for large data sets because you don't want to spend all your time writing them down, right? I don't. Ain't nobody got time for that. All right, and especially if you have a whole bunch of stuff to hold in each stem. Also, there's no magic number for stem seeds. 5 is a good minimum of stems. If you have fewer than 5, split it. If you don't have enough stems, you can't see a good shape on your distribution. Now, if you split stems, be sure to split them equally. In other words, you noticed before I did the first top stem would have 0 through 4. There's the bell. Second period. And then the second one would be 5 through 9. Sorry, too much noise. You know how I get distracted. It's like, squirrel. Oh, good. Okay, let's go. And then sometimes you need to round the data. And there's more information on rounding the data on page 34 in your textbook. Right above check your understanding. You should be able to find a little bit more. Sometimes it's just easier, especially if you're talking salaries or something. We don't need to go to every single number. If you're doing something in the thousands, it's just easier to round the data. All right. All right, so the last thing we're going to look at this, I know this is a very long lesson, is histograms. Now, often we have too many data points to use a dot plot or a stem plot because they're just too much. So we want to group the data in a range, and the most common graph of this is called a histogram. These look like bar charts, or bar graphs. Well, everybody needs to go to middle and upper school right now. They look like bar graphs, but they, the horizontal axis, sometimes you do it on vertical, but most of the time we'll do horizontal axis, is a range of values. Instead of categorical in bar graphs, we're going to do range of values, and we call these classes. You know, and I don't think it says this in your book. You usually, and when you're looking at classes, you want to do 5 to 7 classes are pretty common. If you do too many, it just gets bulky. And to determine the class width, and some software will just do it for you, but to determine the class width, which will make sense in a minute, you just take the range divided by the number of classes, and then you'll know how wide to make them. So it'll make more sense when we do some. All right, as we look into a histogram, let's start off by determining our classes and the width of each one. Now, if you look at this data happens to go from 1.2, the range is 1.2 to 27.2. So that means we have a range, excuse me, that would fit, I would say, let's go with 5 classes. And so we really need to go, starting at 0, we know 0 would be lower, and 30 would be higher, so that would work. I'm going to work with classes between 0 to 30. You just want to make sure you have something below and above. So if we have 5 classes, you know, the first class would be 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. So technically we have 6 classes. Sorry. Now, here's the issue. You'll notice that I've got an overlap here. And I don't want data to fall. If I have a data of 2.5, sorry, or 25, I don't want it to fall on a line in my graph. So really what I mean by this is my first class is going to be 0, to anything less than 5. My second class will be 5 to anything less than 10, and so on. All right, so now we're going to find the count, and to find the count, we're simply going to count from our data table and put it into our frequency table. Notice that this is called a frequency table because it talks about the frequency of which something occurs. So if I look at my chart, I could count them. Now I've already counted these up, and I know that there are 20 between 0 less than 5, 13 less than 10, 9 less than 15, 5 less than 20, 2 less than 25, and 1 less than 30. And I have a total, if I add those all up, of 50. Now, this is a frequency table. It simply measures the frequencies of which something occurs. But notice, I also have something called a relative frequency table. Whoops. Sorry, guys. A relative frequency table. Well, I don't know why that is just being a pain. Relative frequency. Now, relative frequency is where we take the count, divide it by the total, and get a percent. Notice that this is percent here. So the percentages, I've already figured this out. We have, let me go back to red, 40%, 26%, 18%, 10%, 4%, and 2%. And if I add those up, I better have 100%. All right, so now we want to label and scale our axes and draw our histogram. And I'm sorry this kind of came out a little funky, but hopefully it will work. This is the, this question has to do with people born outside. All right, so I wrote all this out and it didn't record, so I'm going to hope that I can walk you through it. So here we go. The shape is skewed to the right. It has a single peak, and you can see it's skewed to the right because it goes from left to right, and the tail's longer on the right. We know that the center has a median somewhere between 5% and 9.9% because we know there's 50 possibles and 20 of them are used right off the top. So we know it's going to fall somewhere in there. The spread, the only thing I've really given you to work with is the range, and the range is 26%. And the outliers, based on these graphs, I don't really see any outliers. It doesn't look like there's any data that's separated by any space. It looks pretty uniform, uniformly skewed to the right. Now I'd like you to take a look in your book on page 37, and there's some graphs at the bottom of the page in which they divided the class width in half. So instead of 0 to less than 5, it's 0 to less than 2.5. And what that does is it gives us a much more detailed look at what's happening in the graphs. All right, well, we need to use histograms wisely. So let's hit a few things and then you'll be ready for your homework. First of all, don't confuse histograms with bar graphs. They look the same. But remember, bar graphs are for qualitative data only, and histograms are for quantitative or qualitative data is bar graphs, so categorical in your book. And histograms are for quantitative. Do not use counts in the frequency table or percents in your relative frequency table as data. The counts are frequencies, and we sort of talked about this the other day when we were trying to determine if it was qualitative or quantitative when somebody answered a question of yes, no. When we tally mark and we are taking counts, those are just counts. We're gonna use that to graph our bar graph. The next one, use percents instead of counts on the vertical axis when comparing distributions on many different numbers. The percents or the relative frequency just gives you a little bit better indication because you're seeing the percent of the whole. Now, not all graphs are useful, histograms or any graphs. Just because a graph looks good doesn't mean it is meaningful. We have to use the appropriate graph at the appropriate time. If we don't, then we're just going to confuse our reader, and we will not be using statistics wisely in order to be truthful about our information. This concludes this lesson, and hopefully you have enjoyed it, even though I feel like I ramble and it just is awkward. And right now, you know what? I'm in the little room, up in the lair. What do we call this? The conference room, but I feel like I'm in an interrogation, and it's echoey and it's weird. And now I hope I made you laugh. I'll see you in class on Thursday. Bye.